Okay, now done. For the circuit shown in figure, for the circuit shown in figure, determine the load current IL using Norton's theorem. Using Norton's theorem. This is a diagram. You copy down this diagram. This is an inductance and this is the resistance and this is the capacitance. Here there will be a one voltage source and it is direction it is like this and it is value will be 5 at an angle of 90-degree volt. And here also there will be a one voltage source that is 10 at an angle of 0 degree, 10 at an angle of 0 degree, and it is circuit is like this. The value will be, this is your J3 ohm and this is your minus J2 ohm and this is the current that is IL and this value will be 5 ohm. In this circuit, you have to find out what is the current flowing through the IL by using the Norton's theorem. That means here load resistance will be 5 ohm. What is the procedure to follow the Norton's theorem to find out the Norton's current means? Short the load terminals. Reread this diagram. This is your short this load terminal and what is the voltage source here that you have to write. This is your 10 at an angle of 0 degree and this is your J3 ohm and this is minus J2 ohm and here also there will be a one voltage source that is 5 at an angle of 90 degree. Okay, short this and find out what is the current flowing through this branch, that is your Norton's current. Short circuit current is a Norton's current. So how to find out your Norton's current? Assume the loop current. This becomes a two loops now here. Assume the loop current. You take this as I1. Another loop current. You take this as I2. Okay. Find out what is the I1 now. Apply KVL for the loop 1. When apply the KVL loop 1, we can write it as for the loop 1. We write it as a J3 into I1 minus 10 at an angle of 0, that is equal to 0. Therefore, I1 is equal to 10 at an angle of 0 degree divided by J3. This is 10 at an angle of 0 degree divided by 3 at an angle of 90 degree. And this is equal to minus J 3.33 amps. 33 amps, or you can write it as 3.33 at an angle of minus 90 degree amps. This is our I1. Similarly, you apply KVL for the loop 2 and find out what is the current I2, that is minus J2 into I2 minus 5 at an angle of 90 degree is equal to 0. So therefore I2 is equal to minus, that is 5 at an angle of 90 degree divided by minus J2, that is equal to 5 at an angle of 90 degree divided by 2 at an angle of minus 90 degree. Okay, this is equal to 2.5 at an angle of 180 degree amps. This is your I2 current. Looking from the diagram, what is the I1? In this I1 here, both the current will be adding because now here, so one current it is I1, it is like this
Yes,
I1
I that's
and
right.
I2 is also in the same direction and both the current will be adding now. Therefore, IN is equal to I1 plus I2. I1 is equal to I1 plus I2. Add the both the current, then we can write it as 3.33 at an angle of minus 90 degree plus 2.5 at an angle of 180 degree. Further, you simplify this. This is we can write it as minus, okay, minus J. This is sorry, this is only 2.5 minus 2.5 minus J 3.33 amps. This is equal to 4.164 at an angle of minus 126.89 degree amps. This is your Norton's current. Next, what you have to find out? What you have to find out one more?
Norton's resistance.
Norton's resistance. Norton's resistance is nothing but a equivalent resistance. Equivalent resistance, right? So that is your Norton's resistance. Norton resistance, or we can call it as a equivalent resistance itself is a Norton's resistance. How to find out this? Open the load terminals. I open the load terminal here and short the voltage source. This is the voltage source I shorted, and another voltage source that I shorted. Okay, this value will be here inductance, and this is a capacitance here. This inductance value will be J3 ohm, and it is minus J2 ohm. Okay, looking from this terminal, find out what is the equivalent impedance. So what is the equivalent impedance? Zn is equal to Z equivalent is equal to, these are connected to parallel, no? J3 into minus J2 divided by J3 minus J2. This is J square is minus 1, minus into minus plus 6 divided by J1, that is 6 at an angle of minus 90 degree, that is minus J6 ohm, minus J6 ohm, that is 0 minus J6 ohm is the impedance. Is it clear up to this?
Yes, sir.
Okay. Next, you have to connect the load and find out what is the current flowing through the load. Write a final circuit, that is write a Norton's current here. So Norton's current, this is your Norton's current, right? And here that is Norton's impedance. This is the Norton's impedance. This is Norton's current is 4.164 at an angle of minus 125 point. How much it is? Norton's current
minus
126.89.
128.
126.85.
Okay, 126.89 degree amps, and this is minus J6 ohm. Here you have to connect the load resistance here. This is your 5 ohm. In this branch, you have to find out what is the IL. What is the IL now? There is a current division formula, you know. That is IN. That is 4.164 into minus 126.89 into minus J6 divided by sum of the resistance. Minus J6 plus 5. After simplification, we'll get 3.1988 at an angle of minus 166.69 degree amps. You have to find out like this. Is it clear?
Yes, sir, can you go back to the previous slide 1 second, sir?
Previous slide ಇದೇನೋ ಓಪನ್ ಆಗ್ತಾ ಇಲ್ಲಪ್ಪ, ನೋಡ್ತೀನಿ ರೀ. ಓಕೆ.
1 second, sir. Done, sir.
ಓಕೆನಾ?
Okay.
Okay. Is it clear? Any doubts? Any doubts? You can ask me. Otherwise, let's go to the next problem. Shall I go to the next one?
Yes, sir.
Yes, sir.
Okay. Now write down. Obtain the Thevenin equivalent network. Obtain the Thevenin equivalent network for the load RL in the network shown in figure. In the network shown in figure. This is the diagram. This is the diagram. This is there will be a one resistance and there will be a one voltage source, and here there will be a current, and here there will be a resistance, and this is here dependent voltage source, and here there will be a resistance. This is where 2 volt and this is a 2 ohm. This is labeled as a Vx, and this is 2 amps, and this is 1 ohm, and this is minus plus 4 Vx, and this is the load resistance, it is RL. He has to find out what is the Thevenin equivalent circuit. That means you have to find out a Thevenin voltage and a Thevenin resistance. How to find out a Thevenin voltage? How to find the Thevenin voltage? What is the procedure to calculate the Thevenin voltage?
Sir, open circuit the current source and short circuit the voltage source.
No. Open that is for only if it is contain independent sources. But when it is contain a dependent voltage sources, what is the procedure?
Determine the open circuit voltage.
That is open the load terminal. Open the load terminal and calculate the open circuit voltage
Open
with
circuit voltage and
with
short circuit.
with sources activated. With sources activated, find out the Thevenin voltage. Okay, don't short here when it is a dependent voltage source. Now find out what is the open circuit voltage. Now in this diagram, what is the open circuit voltage? 4Vx plus Vx. That is our open circuit voltage. That is a Thevenin voltage. How to find out Vx? In this case, in this diagram, KCL is the best method. So apply KCL at node Vx. So apply KCL at node Vx. So Vx minus 2. Current flowing to that branch is Vx minus 2 divided by 2. Current entering the node minus 2. And this branch, current will not flow, no? This is open circuited. So current will not flow in this branch. Therefore it is 0 only. Plus 0 is equal to 0. That is Vx minus 2 is equal to 2. That is 4. Then we can write it as a Vx is equal to 6 volt. Okay. Then what is the Thevenin voltage? Okay, looking from the diagram, what is the Thevenin voltage? This is the voltage, no? Voltage across 4Vx. This voltage you have to take. This is the Thevenin voltage, open circuit voltage. Here, in this open circuit voltage, that is 4Vx, drop across 1 ohm is 0 because it's open circuit, there is no current flow, there is no drop. Then the voltage from here to this point, that is Vx. So therefore, what is the Thevenin voltage? That is equal to 4Vx plus Vx. We calculate a Vx, 4 into 6 plus 4, that is 24 plus 4, that is equal to 5Vx, no? 6, 24.
28, sir.
28 no. 1 Vx plus 4Vx. Vx is equal to 6 now here.
Yes, sir.
30, sir.
30.
24 plus 6, sir.
6. This is 6 now here. Here that is 6. 6. That is 30 volt. Or you can write calculate here now. That is 5Vx. Then Vx substitute 6. 30 volt. Then Vx is equal to 30 volt. That is Thevenin voltage will be 30 volt. Understood now this concept?
Yes, sir.
Next, calculation of a short circuit current. You have to find out a short circuit current. Calculation of short circuit current to find a Thevenin resistance. Short circuit current means short the load terminal. Short the load terminal. This is your short the load terminal here. This is our 2 ohm and this is a 2 volt, 2 amps, and this is 1 ohm. This is minus plus, and this is our 4 Vx, and we have shorted this terminal. We take this as a short circuit current, and here you can take this as a Vx, right? How to find out a short circuit current? Again, apply the KCL at node Vx. KCL at node Vx. KCL at node Vx. The current flowing to this branch, left hand side branch is Vx minus 2 divided by 2. Current entering minus 2 plus Vx. What is the current flowing to this branch?
ISC.
ISC.
Short.
ISC. What is the formula? Node equation. I written now Vx minus
Minus IS.
Vx.
Plus
Here I take
4 plus 4 Vx.
correct. Vx plus 4 Vx
divided
by 1. If it is plus minus, then you can take Vx minus 4Vx by 1. But it is minus plus, therefore you have to take Vx plus 4Vx1 is equal to 0. This itself is a short circuit current here, that branch short circuit current. So find out what is the Vx in this case. So this is 0.5 Vx minus 1 minus 2 plus 5 Vx is equal to 0. 5.5 Vx is equal to 3. Vx is equal to 3 by 5.5. How much it is?
0.54.
0.545 volt. Volt. Okay. So now what is the ISC now? Short circuit current is equal to current flowing to this branch is Vx plus 4Vx by 1. That already written now here. Same. Vx plus 4Vx divided by 1, that is equal to 5Vx, that is equal to 5 into 0.545, that is equal to 2.73 volt. Then how to find out a Thevenin resistance now? Thevenin resistance is given by open circuit voltage VTH divided by short circuit current. That is 30 divided by 2.73, that gives 10.98 amps. So here this is the your Thevenin circuit, open circuit voltage, and so the Thevenin resistance. This is 10.98 ohm, and this is voltage will be 30 volt. You have to solve like this. Is it clear?
Yes, sir. 1 minute. We are copying now.
Otherwise, you can do one thing. I shared already notes. You can download. You can take a printout. You can observe there while explaining there.
Okay. Done, sir.
Then okay. Any doubts? Go to next one. No, the next. State Norton's theorem. State Norton's theorem. Determine the Norton's equivalent circuit. Determine the Norton's equivalent circuit across AB terminals across AB terminals in the network of figure shown. In the network of figure shown.
Across.
Across AB terminals. AB terminals in the network of figure shown. In the network of figure shown. Hence determine current in 5 ohm resistor. Hence determine current in 5 ohm resistor. So this is a diagram. Note down the diagram. That is circuit. This is where 4 ohm, and here this is minus plus 6ix, and here there will be a resistance. Here another voltage source. This is plus minus, and it is connected here. This is 20 volt, and here one more resistance, it is connected here, and it is here 6 ohm, and this is 5 ohm. This is terminal A, B. This is the point A, B. Here they're given as Ix. What is the load here in this diagram?
5 ohm.
Huh?
5 ohm, sir.
Yes, correct. 5 ohm. To find state Norton's theorem, state the Norton's theorem. That case 2 marks. Remaining for the solving the problem, it will be 8 marks. Totally, this is a 10 marks problem. To find out the Norton circuit, what you can find out? First, you have to find out a
First, Thevenins circuit.
short circuit current that gives a Norton's current. Then you find out what is the open circuit voltage. Then Norton's resistance is given by open circuit voltage divided by the short circuit current. So therefore, to find first short circuit current, that is equal to Norton's current. To find out a short circuit current, short the load terminal. Short the load terminal. So I am shorting the load terminal here. This is positive, negative, and here this is 20 volt. Okay, and this is 4 ohm, and this is the 6 ohm. Here they mentioned the current as Ix, and this is your 6Ix. Short the load. This is I am shorting the load terminal. Okay, this is our short circuit current in this. Then looking from the diagram, what is the Ix now? This is a very important concept in solving this problem. What is Ix?
20 into 6.
0, sir, 0. Ix is 0.
Ix is 0. Ix is 0. This is very important because now here we are shorted. The current will not flowing to this branch. Whatever the current will be coming shortest path only. Shorted path only. Therefore here Ix will be 0. Ix will be 0.
Then we can
And
remove.
if it is shorted means this also short only. Then we are getting a circuit like this. Then we can write a circuit like this. This is your minus plus, and here this is shorted, and here also resistance, and this is your voltage source. Okay, and this is 20 volt, and this is your 4 ohm, and this is your 6Ix. Okay, and this is your short circuit current ISC. Anyhow, it's given already ISC. You can assume the loop current same as the ISC only. Then you can apply the KVL. When apply the KVL, what you can write? Apply KVL minus 6Ix minus 20 plus 4 ISC is equal to 0. Okay, Ix is 0, therefore it is minus 20 plus 4 ISC is equal to 0. then 4 ISC is equal to plus 20. Therefore, short circuit current is equal to 4 by 20, that is equal to 5 amps. This is a Norton's current. That is Norton's
Sir, it's
current is a short.
20 by 4, sir.
Huh?
20 by 4.
Another?
IS is 20 by 4, sir.
Illa.
4 by 20.
Okay. 4 20 by 4. Okay. That is 5 amps. Short circuit current is 5 amps. Is it clear? Next case, what to do to find a open circuit voltage that gives your Thevenin voltage. Open circuit voltage, how you are finding? Open the load terminals in the
Open the
original.
load, sir.
Open the load terminal. Open the load terminal here. This is positive, negative. This is open the load terminal here. This is the point ETC A and B. This is our 6 ohm and this is minus plus. This is our 6IX and this is our 4 ohm and this is 20 volt. Open circuit voltage is nothing but voltage across AB. Okay. How to find out a voltage across AB? In this branch is mentioned IX.
Same as voltage.
Huh?
Nothing, sir.
Hello, tell me, is it right or wrong? No problem. How to find out AB, voltage across AB?
It is same as voltage across 6 ohm.
6 ohm. How to find out voltage across 6 ohm?
KVL.
KVL.
KVL. Apply KVL. Find out IX. Apply KVL. Apply KVL. Then you can write minus 6IX plus 6IX. IX, as you can confusion, no? Mark the IX loop current. Minus 6IX plus 6IS minus 20 plus 4IX is equal to 0. This will cancel. Then 4IX is equal to 20. Then
Ix
IX
is equal to
IX is equal to 5 amps.
yes, sir.
5
Yes,
amps.
sir.
What is the open circuit voltage or Thevenin
30
voltage
volt.
or voltage
IX
across
into
AB is equal to 6 into IX.
IX.
That is
30.
30 volt. What is the Norton's resistance? Norton resistance is given by open circuit voltage divided by short circuit current. Open circuit voltage is 30 and the short circuit current is a 5.
6.
That is your 6 ohm. Understood? Now write a Norton circuit. Norton's current. Write a Norton's current. Write Norton resistance. This is your Norton resistance. Then what you have to write? You have to write a load terminal. This is the load. This is your 6 ohm. Load is 5 ohm. Norton's current is 5 amps. Okay. Then find out what is the current flowing through the IL. What is the current flowing through IL is equal to 5 into 6 divided by
6 by
5 plus 6. That is 30 by 11. That is equal to 2.727 amps. This is the answer. Any doubts?
No, sir.
Is it clear? If you have anybody facing the problem, if you are not understanding, you can ask me. Otherwise, I'll go to the next problem. Over. Shall I go to the next problem?
Just a minute, sir.
Yes, sir.
Or
Yes, sir.
okay, we'll go to the next problem. Using Norton's theorem, find the current through the load impedance ZL in
Repeat,
figure.
sir.
Using Norton's theorem, find the current through the load impedance ZL shown in figure. Note down this diagram. This is 1K and here it is IA, and this has a given ZL as a 667 ohm. But he should give RL, but he has given in the exam ZL. But this is a RL only. This is actually ZL is given. No problem. Is mentioned ZL instead of RL. Using Norton's theorem, find the current to the load impedance. He asked in one exam for 8 marks. So what is the procedure? Open circuit voltage. Open the load terminals. Find out open circuit voltage with sources activated. Short the load terminals. Find out a short circuit current. Then Norton's resistance is given by open circuit voltage divided by short circuit current. Then write the Norton circuit. Write the load. Find out what is the IL. Find out. Similar problem. Similar the previous problem. Only thing is they have changed the values. Solve and tell me the answer. Aishwarya, answer attendance.
Present, sir.
Aishwarya GS.
Present, sir.
I Siri absent. Akash.
Yes, sir.
Amrutvi. Anamika.
Present, sir.
Anirudh.
Yes, sir.
Ashwini KV.
Present, sir.
Ganesh B. Bhavani.
Present, sir.
Bindu.
Present, sir.
Chandana.
Present, sir.
Chandramohan Reddy.
Present, sir.
Chirag Gowda.
Present, sir.
Chirant.
Present, sir.
Darshan.
Yes, sir.
Darshan Ubale.
Present, sir.
Deepak Gowda.
Present, sir.
Deepak R.
Present, sir.
Dinesh K.
Present, sir.
Disha.
Present, sir.
Gagan.
Yes, sir.
Ganashri.
Present, sir.
Arshit.
Present, sir.
Hemant C.
Present, sir.
Hemant Devendra,
Yes, sir.
Hitesh Kumar, Hitesh,
So he's in
Jannavi.
class, but he's not
Present.
able to unmute it seems.
Okay, Jannavi,
Present, sir.
Varun KB,
Present, sir.
Deepak K,
Present, sir.
Kantaraju,
Present, sir.
Kavya,
Present, sir.
Kirtana.
Present, sir.
Okay, solved a problem.
Sir, Ganesh is also present, sir. He raised his hand.
Okay, Ganesh. Next, that's all, no? Got answer?
1 minute, sir.
The VOC is equal to 1.33 volts.
1 second. Madam, class ಏನದ
Sir, VOC is equal to 1.33 volts, sir.
Sir, is load current 0.99 milliamps.
1 milliamp, sir.
1 milliamp, 0.99.
Hello.
Yes, sir.
Got answer?
0.99 milliamps.
1 milliamp.
So VOC is equal to 1.33 volts.
Yes.
Correct. ISC?
Is
2 milliamp.
milliamps.
2 milliamps.
ISC 2
milliamps.
milliamps, correct.
2 amps.
2 milliamps.
Yes, sir.
Rotor
Yes.
resistance?
0.66.
667.
0.66 ohm, sir.
Kilo ohms, sir.
0.66 kilo ohm. That is
That is 667 ohm.
5 or 665 ohms.
667
Yes.
ohms.
What is IL?
0.99 milliamps.
1 milliamps, approximately 1 milliamps. All of you got this answer?
Yes, sir.
Then it is
Yes.
correct. That's the concept is important. And don't confuse what is open circuit voltage, what is Thevenin voltage, what is Norton's current, short circuit current. That you have to remember. Procedure you have to remember to calculate this. Next one more. Next similar problem he asked, but resistance value is given as a different. Okay, that is instead of this one here 667 is there, no, they're given a 67 ohm, 67 ohm, sorry, 67 ohm, same problem.
Everything else is same, sir.
Everything is same. Instead of 667 they're given 67 ohm, remaining is same procedure, same only calculation. Okay, Next, note down. Obtain the Thevenins equivalent of the network. Thevenins equivalent of the network shown in figure between the terminals X and Y. Between the terminals X and Y. Also find V naught. Also find V naught. This is the diagram. Note on this diagram. This is our 6K and this is 4K and this is 3K and it is 2K. This is 12 volt and this is the point, it is XY and it is a here, it is a V naught. So obtain the Thevenin equivalent of the network shown in figure between the terminals X and Y. Oh, I will do this for your Thevenin voltage.
Sir, we will find Norton circuit and then convert it into Thevenin's.
That you can do that also, or simply you can do directly, you can calculate Thevenin.
Yes.
You can do any
Thevenin
method, no problem. No, you can do any method. Here, what is the load here?
Load is not given, sir.
Load is 2K. Obtain the Thevenin's equivalent of the network shown between the terminals X and Y. Okay. That means X and Y.
Sir,
X and Y is a load. 2K is a load. Right. So that means you have to find out what is the that is the load. Remove the load and write a circuit first in this diagram. To find out this open circuit voltage, remove the load and write a circuit. So this is your load. I remove the load here and it is connected this point. One more resistance is there, no? That is your right. This is your 4 milliamps. 4 milliamps and it is connected to here, this point. Okay. And this is your 6K and this is 4K and this is your 3K and this is your 12 volt. Remove the load terminal to find out a VOC here. Okay. So to find out a VOC now here, open circuit voltage. Remove the load terminal. I remove the load terminal. Then what is the open circuit voltage here? VOC is nothing but a VTH, right? Open circuit voltage, that is voltage across 4K and voltage across 3K. Understood now here? What is the VAB?
Yes, sir.
VAB is nothing but a voltage across the 4K plus voltage across the 3K. To find out this, You can assume the loop current here. This is your one loop current, that is I1. Anyhow, is current already 4 amps is given. Assume in the same direction, that is will be same direction. It is this you can assume as a another current, that is I2. Looking from the diagram, what is I2 now? I2 is equal to
4 milliamps.
4
milliamps.
milliamps. 4 milliamps. Okay. Then apply KVL for the loop 1. For the loop 1, apply KVL. Then you can write it as 6 into 6K into I1 minus I2. I1 minus I2. I1 minus I2 plus 3K I2 minus 12 is equal to 0. Find out what is the I1 in this case. 6K I1.
3K I1 no sir.
Yes, correct. 3K I1. This is 3K I1, correct. $3K into I1 is equal to 12. 6K I1 minus 6K I2 plus 3K I1 is equal to 12. So this is
Minus 1.333 milliamps, sir.
how much it is. I1 you have calculated, huh?
Yes, sir.
How much?
Minus 1.333 kiloamps. Sorry, milliamps.
Minus
4 million.
minus
4 milliamps,
4
sir.
milliamps sir.
4 milliamps. Okay, 4 milliamps, correct. 4 milliamps is the correct answer. Then what is the open circuit voltage? VAB is equal to voltage across the 4K, that is 4K into I2 plus voltage across the 3K, that is 3K into I1. VAB, following now? VAB is nothing but, here observe the diagram, I will show you. This is the voltage. That means voltage across this 4K resistor, voltage across 3K resistor. That gives your VAB. That is your open circuit voltage.
Okay, sir.
How much?
28 volts, sir.
28 volt. Don't confuse us. Sometimes you are telling the open circuit voltage, sometimes you are telling a Thevenin voltage, sometimes you are telling the VAB. Don't confuse. These all are same. That is a procedure. Understood now? ಅರ್ಥ ಆಗ್ತಿದ್ಯಾ? ಹಲೋ.
Yes, sir.
Yes, sir.
ನಾನು ಅದೇ ನೀವೇನು ಸರ್ ಓಪನ್ ಸರ್ಕ್ಯೂಟ್ ವೋಲ್ಟೇಜ್ ಅಂತೀರಾ, ಒಂದ್ಸರಿ VAB ಅಂತೀರಾ, ಒಂದ್ಸರಿ ಥೆವೆನಿನ್ ವೋಲ್ಟೇಜ್ ಅಂತೀರಾ ಅಂತ ಕನ್ಫ್ಯೂಸ್ ಮಾಡ್ಕೊಬೇಡಿ, ಎಲ್ಲ ಸೇಮ್ ಅದು. Right? So VAB is equal to 28 volt. That is your Thevenin voltage. That is your open circuit voltage. Then what is the Thevenin resistance? Open the load terminals, find out what is the total resistance. Now here in the above diagram, so this is resistance and this resistance and this is the resistance here. The voltage source you have to short it, open the current source and find out what is the RTH. That is your 6K and this is the 4K, right? And this is your 3K. Then how much you are getting RTH? 6K into 3K, 3K divided by 9K plus 4K. This is in series.
6 ohms.
6K, sir.
6K. 6K.
6K.
6 kilo ohm, correct. Right. Next, this is where you find out a Thevenin's network over. You find out a Thevenin voltage and the Thevenin resistance. And he asked one more. What is asked now? To find out V0, also find V0. V0 is what? Voltage across
Voltage across 2K.
2K.
Lots.
Voltage across 2K. You have to read the questions very carefully. Voltage across 2K, right? To find out a voltage across 2K, what you can do now, you have to find out what is the current flowing
IL
through
into IL into
IL.
load into current flowing.
Okay, you can find out that method. Verify. I'm telling another method here. Now voltage across 2K here. Assume the loop current here. This is where I1. This is another loop current. This is I2. And this is assume the loop current. It is I3. I3 is equal to 4K. Okay. Find out
4K.
what is I2. Then V0 is equal to 2K into I2. That gives your 7 volt. This is a V0, right? Similarly, you find out Deepak, you find out also that method also. Are you getting 7 volt or not? You'll get the same or not using the Thevenin resistance and Thevenin and calculate the voltage and tell me the next class.
Sir, 8 volt no,
Sir,
sir.
7 volt only will get, sir.
Other 7 volt? Okay.
Yes, sir. Thevenins equivalent circuit ಬರ್ದ್ಬಿಟ್ಟು find ಮಾಡೋದು sir.
ಎಷ್ಟು voltage?
7 volt.
7 volt. Then that method is also correct. Okay. Any doubts? Okay, then I will close the sessions. We'll continue in the next class. Take care. Bye.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you.
Yes, sir.